Keep wanting to get by the high school and turn in grades, and his papers are graded. I just kind of working on final exams and stuff like that, redoing them. Hopefully, trying to make them not super hard, but so this is our topic for today. If you have your book, it's section 4.5. Give it a couple minutes here. All righty. Well, I think we'll get started. This is a technique that we use for a little bit more difficult problems. These problems look like they're a little tougher to distribute or to kind of work out. And so we use this technique called U subs, where we're going to substitute the letter U for an expression. But sometimes that's not as easy as it sounds, because sometimes it's hard to know what expression to substitute for. So I'm gonna write down this problem number 5. This is example 5. This is a fairly easy one, and then we're getting to some tougher ones. So this is the integration of 3x squared. Now, normally, you can simplify these expressions and then take the integration. Just like derivatives, you sometimes want to simplify them. But this is raised to the 10th power. So we can't distribute into it because we'd have to raise it to the 10th power, which would be a huge mess. So we can't really do that. So we're kind of stuck. So we're going to let U equal something in this particular problem. We're going to replace this, which seems like the major part of the problem right here. And we're going to call that U. You could call it any letter you really want, but they usually just use the letter U. And then what we're going to do is we're going to take the derivative of this expression that we just took out, this x cubed plus 3. So we have to go back and think about how do we do derivatives. We're going to multiply the 3 times the x, and then we're going to subtract 1 from the power, and we get the derivative of 1 is 0, right? And then what I'm going to do is multiply both sides by dx, or sometimes I just think I'm cross multiplying. make it a little faster so I can cross this off and put the dx up here. So if you notice now, I'm going to rewrite this as x cubed plus 1. You don't always have to do this, but when you're starting out, it might not be a bad idea. So this expression right here, let me circle this with red. Oh, I forgot my power. We need the 10 up here. Okay. Oh. I can't recover that either. Get a little too fancy. I'll write it again. Don't forget the dx because it's kind of important on these problems. And we said u equaled x cubed plus 1 to the 10th. No, not to the 10th, just x cubed plus 1. Du equals over dx. 3x squared plus 0. Let me cross this off, put this up here. Okay, now we're ready. So I was rewriting this as x cubed plus 1 to the 10th. This would not be really like a great thing to do your work on because you could have it all done and then bump it. Okay, so what I want to do is I want to look at this part right here. And that is equal to u. So I'm going to write this as u to the 10th. And this whole thing is equal to du. So now I have this problem in terms of just a kind of a simple little tiny problem that I can solve by using integration. This will be u to the 10 plus 1 will be 11 over 11. And the du goes around away plus c, okay? So I've renamed this. I did the integration of it. Now what I'm going to do is I'm going to replace all this now with its value. U is actually this. So it's going to be x cubed plus 1 to the 11th power over 11 plus c. And that's the integration of this problem. So what you have to do is you have to take account for each member that's under this integration sign. We have to take into account for this 3x squared, which we did over here. We got to take into account for the x cubed plus 1 to the 10th, which we did, and for the dx. So we have to account for all of these things. The power we just simply kind of brought down. But we have to account for the major elements in this problem. So everything is kind of like a puzzle, and they all have to fit in place for us to be able to do this. Now, if these don't all fit in place, then we have to go to another, maybe other techniques to do this, which are even more involved. Okay, so this problem, everything kind of fit nicely. Let's try another one and see. Let's try this problem right here. This one looks a little confusing. Okay. So again, it's sometimes difficult to know what to let u equal. That's usually the hardest part of this. And you might say, okay, u equals 2x, and then find out that doesn't seem to do much good. But it's kind of obvious on this one. It probably would be this 1 plus x squared. So we're right, but 1 plus x squared, just that element. No, we're not going to write the 2x over it or anything like that. Just 1 plus x squared. Does that make any sense? Maybe not. Okay. So this right here is u. Okay. I don't want to get too fancy here. Okay, now I want to take the derivative of this. I usually put this off to the side, like I did here. Here's my problem. Kind of push this off to the side so I have enough room to do the problem. Okay, and the derivative, now I'm taking the derivative. This would be 0, and this would be 2x. And then I'll move my dx up here, and you see now I've accounted for this. So this problem is now in the form du on the top and 1 plus x squared on the bottom. No, well, what's not right? 1 plus x squared, what's right? U. So it's more in that form right now. All this is du, and all this is u. So now I'm going to take the antiderivative of that, and on this particular one, I could rewrite it this way. It might make more sense. 1 over u times du. So it's in the form 1 over u, which means it's going to be a natural log of u. And then the du just becomes like a 1. So 1 times that. Okay. And then I can rewrite it in a little fast form as the natural log of 1 plus x squared plus c. You don't have to have the parentheses, but sometimes it looks a little bit better. And that's my answer right there. So I've taken this from this form, kind of made it into a problem that's easier to solve. I don't have to look at all this confusing stuff. I can just look at a simple problem, 1 over u times du, which is the natural log of u. So I have to be able to know how to differentiate and how to integrate on these two problems, which is kind of confusing, to say the least. Huh? All right, let's see if there's another one that's a little bit tougher. We did that one, okay. Now, if this was u squared, if this had a power of 2, then I would bring it up to the top and make it u to the negative 2 and that kind of thing. It's only when the power is 1 that this is a natural log, okay? So it's that special case, but, you know, it might not always be true. All right, let's get rid of this one. All right, here's an interesting one. This is example 8. I try this one and see if I can do this one. See, this is one of those that's confusing. What do I let u equal? That's the tricky part. Is it 3x? Is it ln 3x? Is it x? And that's the part that, you know, is usually tough on these problems. U is going to equal, in this case, ln, don't start, 3x. So du, the derivative of the natural log of 3x, let's see if I can remember it. I can't. So I believe it's 1 over 3x times the derivative of it's a chain rule. 1 over 3x times the derivative of 3, which gives me 1 over x, simplified. And then I'm going to move this up to the top, dx. Okay, so let's see if I have this now in order. This is in the form, this is right here is u, takes care of that. And the dx over x, right here, this part right here, is du. So it's in that form. So now all I've got to do is take the integration of that, which is we're going to add to the power. This was a power of 1. Now it's going to be a power of 2. And I'm going to put it over 2 You know, I'm not going to put the plus c. I could, and I'm just not going to write it down right now. And now I'm going to substitute that u is ln 3x. So this is ln 3x. It's starting up again, isn't it? And I worked so hard to fix it. Squared. So let's put this whole thing as being squared over 2 plus c. And I think that's what they have in the book too. They didn't put it, I didn't put that in parentheses, but that'd be okay. So it's ln 3x squared over 2. There we go. Okay, so you follow? It's kind of hard. This is u, all this. And then when we take the derivative, this 1 over x dx becomes du. See, we're substituting that in. Now we can take the integration. Kind of hard to do it with the original problem. Some people can without using u subs, but it's rather difficult, you know. Well, it's pretty much impossible for me, but all right. So getting even worse, let's try this one. And then, yeah, this is a good one to use. X e to the x squared dx. What a mess, huh? And again, what is u going to equal? Well, you know, it's kind of hard to say. On this particular one, I think what we're going to have to do, according to the book, they want u equal this little x squared up here. They said that this part right up here is going to be du. Okay, and then the derivative of that, let's see, du over dx. Can you see that okay? Does the red show up? I want to make sure you can see it okay. Would be, okay, this would be 2x, right? And I bring the dx up here. Uh-oh. What's wrong? We have an x and a dx. I rewrite the problem this way. But I don't have a 2. See, and everything has to match up. So we can use a little technique called kind of rearranging this a little bit. Okay, where's my, sometimes this happens. Now, we can make an adjustment for a number. Like, we can adjust for this 2. We cannot adjust for a variable. We can't add an x or multiply by an x or create an x. We can create a number, but we can't create a variable. So you want to keep that in mind, because a lot of times you're going to want to, oh, let me put an x here. You can't do that. You can do that with a number. So what I'm going to do is I wanted this to be an x dx, but I got a 2x dx. So I'm going to multiply this side by a half. Half of 2 makes 1. And I'm going to multiply the other side of my equation by a half. So what I have now is 1/2 du equals x dx. So what I can do is I can substitute in place of this x dx, I can substitute a 1/2. So that's what I'm going to do right now. I'm going to write this as, I'm going to make this in dark so you can see it. I'm going to write this as e to the, why did I write du there? This should have been u. e to the u, sorry about that, that should have been u. And right here for this, I'm going to substitute 1/2. But a lot of times, save yourself a little bit of work. If I put, I'll show you, if we put the 1/2 du right here, I can move that 1/2 out of there so it doesn't look so clumsy. So I'll put the half in front like that. So when I write it down, I usually write 1/2 on the outside and du on the inside. Now it matches up with what I want to have in here. X dx is my du, and the half is outside, and then e to the u. Now, when I go to take the derivative, e to the u is 1/2. I'm going to keep that. The antiderivative of e to the u is e to the u. So basically that's it, plus c. And now I can substitute in what it was. So it's 1/2 e to the x squared plus c. See, so all of a sudden, if you don't use this technique, all of a sudden this 2 appears and you're wondering, how did that 1/2 get there? And that's what's sneaky about these little problems. Like all of a sudden there's a half in here and there was no half in the problem. So how did that get there? So that's why you have to kind of use this technique on a problem like this, where we can simplify it. There we go. Let's listen up again. Okay. All right, we'll try one more here and see. And are you kind of? It is not an easy technique, especially. It's one of those things that's okay. Let me erase this. Is confusing. We'll try one more here and see if we can do it. Here's kind of a tougher one. This is example 11. They're kind of fun to do. I mean, in a way, I really enjoy doing these problems, but I can remember the first times I saw these. It was it's usually the part where people say, "I hate calculus." Equals. Okay, I don't want to put equals. We're going to just say u equals. And probably u is going to be this mess right here. I probably wouldn't use the, I probably call this to the, well, let's rewrite it. We call that the half power, huh? So let's do it this way. Where's my, I don't know. Probably call it that way. So I'm going to write u equal, and the book says probably to do the same thing. They give you some hints in the book when you first start out, but usually u is kind of the major expression. It's not always, but sometimes it is. So it's going to be x squared plus 3. Okay. So du dx is going to be 2x. Put my dx here. And once again, I got a 5 instead of a 2. So what they did is, there's a couple of different ways you can do it. They factored out the 5 like this and rewrote it like this. Okay, so we're close to that. We got, well, let's actually rewrite it this way. sometimes I like to do this. This is kind of like our du part here, and this is our u part here. Okay. Well, it doesn't look quite like we're supposed to have. We do have the u. It's going to be the half power, but this x dx, we have to get rid of the 2, so I'm going to take a half times this, both sides, and that will cancel out the 2. Now I got my x dx. So now it's in the form 5. This should have been an integral. That's what's looking weird. Okay, and then I'm going to multiply. Oh, I'm going to put the u in here first. U to the half power. And then for the x dx, I'm going to multiply this by 1/2. See, here's my 1/2, and put my du over here. So basically, I have 5/2 times, because 5 was on the top, u to the 1/2. Well, let's see, that would be u. We add 1, huh? So that would be u to the plus 1 would give me 2 2s, would be 3/2. And then I multiply that by its reciprocal, 2/3, plus c. This 2 will cancel out this 2. So I get 5, and u is x squared plus 3. To the 3/2 over 3 plus c. Let's see if that's correct. Yes. So the c doesn't look too good. Okay, so here's my answer to this mess. So you can see a problem like this is a rather difficult problem to do. I don't think I have any quite this hard for you, but and these become kind of fun to do. You know, they're kind of challenging, and the other ones even get worse. Okay, this is not they get worse. So sometimes we have to use a technique called parts. It's more of a formula type thing. And then sometimes we have to use a technique called using tables that are in the back of the book, or we use a source of tables. We get them. My thing is frozen there. So let's try one off your quiz. Let's see if we can do one. So let's start with problem number 1. Let's take a look at that. This is, we were having trouble. I don't know if it's in the pen or what it is. We've just been having trouble with the styluses. Okay, this is the integral of 2x minus 1 dx over x squared minus x plus 2. So when I first see this problem, I'm kind of visualizing this problem. And when I first see this problem, I see this x squared minus x plus 2 on the bottom. And it doesn't have it has a power here, but I mean, technically it's 2 a power. So this might be a natural log, I'm thinking. You know, it's kind of in the form maybe 1 over u equals the natural log. The integration of that equals the natural log of u. So I'm thinking maybe this might be in that kind of form. And as such, I'm thinking that this part right here is probably my u, okay? So I'm going to let u equal x squared minus x plus 2. It'll probably be the more complicated part of the problem. Then du over dx, we want to write it like that, is equal to 2x minus 1. Taking the derivative, derivative 2 is 0. And I'm I'm going to put this in the parentheses and bring my dx over here. So does it look like it's kind of, we got a 2x minus 1 dx. So that part would be du. And then we have an x squared minus x plus 2, and that part would be u. So just as I was thinking, this is in the form 1 over u du, see? Which is, when I take that out, that's going to be the natural log of u plus c, which in this case is the natural log of, now we're going to substitute, x squared minus x plus 2. You know, if you don't put the parentheses, it's not wrong, you know. And that would be my answer. Oh, plus c. So all the parts fit. This is, it's kind of like building a car, something like that. You can't just jam in, you know, any parts into it. They got to be specific parts. Everything's got to kind of be a match. This u has to match here. This 2x minus 1 dx has to have a match. See, and if we put this, and I think I'm just bringing this up to the top. Technically, what I'm doing is I'm multiplying both sides by dx, but, you know, saves a little time not writing it each time. I put this like here, dx here, and dx here, and then these cancel. See? But I just usually just put it on top and save time. And then that's du over u, which it means the same thing as 1 over u. And when I see something, I know this one's a little harder to spot, but that's a natural log of u. The main ones are the integration of 1 over u is du is natural log of u, and the integration of e to the x dx is e to the x. Those are special cases you want to recognize. Isn't this thrilling? Oh, it is pretty cool stuff. See if I can give you a little bit harder one here. You're saying you just did, you know. Okay. This one is, actually number 2 is kind of tough. Let's take a look at that. Not super, but a little bit harder maybe. So again, taking a chance, what would u equal? Well, you might say u equals 2x, but then du would be just 2, and that doesn't look like that would work. That doesn't incorporate any of that stuff. So you probably want to let u equal this tougher part. But usually we don't include this power that's on the outside. Okay.
Is this supposed to be number 2 on our quiz?
Yeah, do you have that?
Well, mine says x dx over 7x squared plus 3 to the 5th.
Oh, okay. Let me write yours down. This was another test that was similar to yours. I thought maybe this was the one I gave you. Okay, let's write down yours. Actually, you're probably glad you don't have this problem. Okay, let me erase that. Try your number 2. Okay. Yours would probably be a little bit easier than this one. 7x squared plus 3. Yeah, I have your quiz here too. I didn't, this was an older one. Oops, what am I writing here? 5. So what do you think u should equal? I'm thinking u would equal this message side here, huh? This might be an interesting problem. So let's see what du is. I don't have the key on this one made up yet. So that looks like 14x, huh? And put the dx here. So obviously we don't have a 14x. We have an x dx, but we don't have a 14 dx. So it looks like I'm going to have to get this down to looking like x dx. So I'm going to multiply this by 1 over 14. and 1 over 14 here. But different books do this a different way. This is the way I like to do it. Some books do it slightly different, but what I have now is 1 over 14 du. That's what I'm going to substitute, equals x dx. That's what I have here now. See? So that's why I like to do it this way, because I brought this up to the top. I can kind of visualize what I got here. So it looks like I'm already ready to substitute in x dx. We're going to write that as 1 over 14. I'll put that on the outside, and then du. I'm going to put the du here. And then this is going to be 7x. That was on the bottom. So I'm going to put that as u to the 5th. So this would be really 1 over u to the 5th du. So I think on this one, I can actually, this isn't just 1 over u, which would be natural log. This one, I have to bring it up to the top. So this is going to be u to the negative 5 du, like that. So now I'm ready to take it out. Let's see, I'm going to add 1, right? So if I add 1, this would be u to the negative 4 over negative 4 times 1 over 14 that was on the outside plus c. So making that a little bit nicer, this would be a negative 1. I'm going to bring this u to the 4 down. And I'm going to multiply these together. That'd be 56. So I'm going to erase this. So it doesn't look anything like the original problem. Now I'm going to substitute in negative 1 over 56 times u, which is up here, 7x squared plus 3. So quite different from the original problem, huh? Let's see if I have this problem. I don't have that on my key, so I'm going to have to. So that one was kind of a tough little cookie after all, huh? Because of this little 14 thingy here going on. 2 times 7 is 14x. And I had to get rid of it. And then right here, having to bring that up and then change it u to the negative 4, add 1, see. So it's hard. It's a little tricky because here you're subtracting 1 and here you're adding 1. So confusing. I understand these problems. You're doing 2 different operations. You're differentiating and you're integrating, putting it all together. Is there a special one you want to see? Because we don't have too much time left. Can I look here and see? I don't know about number 6. Number 6 looks really hard there, that ln3x. Let's see if we can do this one. This one to me is we don't.
Did we already do number 6? It was like an example.
Oh, was it an example?
I think so.
Oh yeah, it was an example, huh? Oh, okay. Because you know we don't have the integration of ln x is let's see. I can't remember if it might be in the back of your book. That does come up quite often, but you can't do it by u subs. You have to do it by parts. Let's see here, my book is missing a page or something. Let's see here. Oh, here it is. Yeah, it's x ln x. This one comes up a lot, maybe second semester calculus. You run into this problem quite often, x ln x minus x. Let's see, it's just one that you kind of memorize. You can't really do it by U subs. It's a little bit more complicated. So 1 over x is ln x. But the integral of ln x is x ln x minus x. Okay, any others you want to see? And when that's sort of probably number 8 is a little tough, but I'll let you try it. You probably have to, because you got that. It might not be too bad. You probably have to multiply it by a half, something like that, because you're going to end up with a 2x and you got to get rid of the 2. Did we do one like number 4? Yeah, I think we did do one like 4. Yeah, that's example. Yeah, we did that one. All right, so I'll let you try working on these next week. You're going to have, we usually like to do a review for the final, but you're going to get your final. The final will have, it won't have much U subs. There is one problem with U subs, but you have some integration, you have some differentiation. You're going to have to do one problem the long way with the difference quotient. I think, you might be a little rusty on that one. But overall, it shouldn't be too tough. I think there's like 16 problems on it. And try not to make them super hard. And there might be problems where you already have worked on the quizzes. So
How much is it gonna be worth?
it's going to be worth 100 points. The final. Usually I count the final as 200, but I'm just going to count it as 100. You should do pretty good. You can use that. I know you turned in your quizzes. Some of you turned in the quizzes, so you might not have a quiz to reference. That was the only bad thing. If you submitted them by through email, then you probably have your copy. So
Mr. Mitchell,
yes.
on the test, do we get to use our notes or not?
Yeah, you can use your notes and everything else on the final.
Okay.
I'm not going to be there. You can probably use a computer or whatever you want to use. You want to make a good grade, that's fine. Because it's open. It's completely open book. This isn't the usual final the class we give to the class. It's just we were supposed to make up our own finals, so I tried not to make it super hard. It's much easier than their final, and you can use any resource you want. Okay. I think we're going to sign off then. You now know how to use subs. Okay, stay away from large groups, safe distance. It's kind of hitting globe. I see there's more cases. Another case came up yesterday. So, it is out there, I think usually younger people are probably safer. You guys are probably in the safe range. But the problem is you might be carriers and not realize it, and you might give it to somebody else because you don't have any symptoms. So that's the problem, But I think for the most part, our community is pretty safe, All right. See you. I don't know if we're going to have any Zooms. I'll let you know next week. We might do one on Tuesday, but I'm not sure. All right. If not, they'll also post your grades on Gila Hank on around the, let's see if I got a calendar here, around May 6th, 7th, we should be able to post your grades.
Mr. Mitchell, did we get homework this week or no?
Did you not, just your quiz, huh? Just these quizzes?
Yeah, well, the ones you gave us last week, right?
No. Well, this quiz I just went over this problem. Did you get that quiz?
When did you send it on email?
Yes.
When did you send it?
Wednesday of last week.
Oh yeah, I got that one.
Okay, then that would be it.
Okay, so we don't get any new ones this week, or?
But that was for this week. Oh, you mean at the end of the week? By Thursday of this week, I'll be sending out your final exam.
Okay. All right.
Okay, yeah, that's all we're gonna be doing next week is the final. And I do have something on, I didn't put it on the test, so I'm not gonna give you the worksheet on it. It was a thing on the average value theorem. But I'm probably not gonna give you that one. So because it's not on the final, so we won't worry about it. You have plenty of quizzes already in, so. All right, I sign you off and then I try to sign you off. I don't know, I'm having trouble with this thing.
Thank you, Mr. Mitchell.
Okay, we'll see you. Let me see if I can.